Alrighty, folks, let's get to it, shall we? I'm going to turn some lights off to make it a little bit easier for us to see the screen here. As we saw from our earlier explorations of Canvas, today's homework assignment is going to be a house. This is going to be a two-part assignment, okay? The first part is the basic construction of the geometry itself. So I don't want you to spend too much time thinking about materials and textures yet, okay? That's going to be next week as we explore the process of creating tiling textures for the entirety of our scene. So how we texture big environments is a little bit different than how we would texture something a little bit smaller, like a cannon or a bike, an asset, a prop, if you will. So we're going to explore those ideas next week, okay? This week, however, it's all about the geometry, and there's two components to this week's homework that I want to draw your attention to. First and foremost, if you look in the week 9 section on Canvas, here's the actual assignment sheet. This is due next week, okay? One of the big picture ideas that I want you guys to strive to achieve this week is you're going to be building a house and a simple little scene, a landscape that kind of is wrapped around your house, okay? Now, your house can look like any house that you want. It really doesn't matter to me, but it needs to read as a house. And if you look at some of the samples down here, of course, we have good old Bag End, which is kind of fun. Does anyone recognize this house? Dun, 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 dun. It's The Simpsons. You're absolutely right, Anthony. Good job. Okay, and this is just another great house. Okay, this is Bag End from The Hobbit. Yeah, Lord of the Rings. Sorry, I just assumed everyone was a Lord of the Rings nerd like me. But we're making a house in a simple little scene that goes along with that house. Okay, and if you look at the banner image, I think this gives us a really good kind of perspective as to what the render is going to create for us. That we have to fill in the blanks a little bit. We need to create a much larger scene for our house to sit in so that when it's rendered correctly, it reads as a complete environment. So things like fences and sidewalks and maybe even a lawn are good details geometrically to start prototyping pretty early on and included in our final model. Now, to get us started, in addition to completing your bicycle, and if you haven't finished your bicycle yet, remember you still have about another hour and a half of lab time that you need to spend this week on your bike. Okay, try to capture the complete shape of your bicycle, and then transition and move on to the next part of your lab, which is probably, well, it's absolutely something that you're going to want to do before you even start building your house, which is do some research. Okay, everyone thinks they know what their house looks like, right? Until I say build a 3D model of it. Then there's a lot of questions that naturally bubble to the surface. So doing some research on a house or just houses in general will help arm you with the correct information that will help you in your modeling decision-making process. We all think we know how big or what a window looks like until we're asked to make one in 3D. The reference research that we do will help us establish those small little micro details. So that when it comes time to build a window, we have maybe some images that will help us understand the structures that we're going to create. It's the most important part of every assignment. Okay. Now going forward, you're going to be doing a lot of this on your own. Okay. All the assignments are going to be things that you choose to build. So they're going to be your projects. So you need to have a good collection of reference that will help you kind of take you down a path. Now, when it comes to the reference itself, the research that you're going to do, there's no expectation that you build that house, right? Because you're going to be pulling reference from a lot of different visual sources. Hopefully, if you can find blueprint drawings for a house, that's a great place to begin. But if you find blueprint drawings for a house and then build something else, that's cool too, right? Because those blueprints are still really valuable. It kind of pre-bakes your oven a little bit. It starts getting you thinking about how all these forms work together to create a house. Houses are more complex than I think a lot of folks kind of give them credit to be. They're more than just kind of a big box, right? They're a whole series of really compound angles and different planes intersecting to create a really interesting volume. Pop quiz, does anyone recognize the house in the banner image? I always like to do this. This is fun. Anyone? Anyone? Huh? It is a mansion, obviously, but it's the Haunted Mansion from Disneyland, which is pretty cool. Yeah, it's the Haunted Mansion from Disneyland. It's the plans, the blueprints for the Haunted Mansion. So I want you guys to go out and find some good reference, some blueprints, some diagrams, something to help you understand exactly what all this is going to be put together. And then you're going to build a house from there, okay? Now, you're going to need about 10 of these things, and then when you're done, just zip them up, make a compressed archive of these files and just submit them to Canvas and you'll be done, okay? This is about 20 minutes worth of work, okay? It's the easiest 25 points you'll earn all semester long, okay? It really is. Yeah.
I have a question.
Sure.
It's going to sound really unserious, but I built a lot of houses in The Sims 4. Is it okay if I take some references from that?
Absolutely. Yeah, for sure. No, I think that's fine. Yep.
Okay.
All right. So let's...
So we just have to like upload some like blueprints basically?
Yeah, just some reference images, some research. I want you guys to start kind of looking at pictures, which will get you starting to think about houses, how they're put together, their structures, their forms. You know, if I was choosing to build this model, I would try to find as many pictures that capture the Haunted Mansion from Disneyland as I possibly can, right? Yeah, that's thousands of pictures, if possible. Whenever I do research, well, whenever as 3D modelers, we kind of need to turn into like subject matter experts on the thing that we're building, right? We need to know it inside and out, how this thing is fundamentally, physically created from the bricks, you know, up, from the foundation up, okay? So that we can build an accurate representative 3D model of that shape. It's the most important part of any creative endeavor, just doing the research, figuring out what it looks like before we can build it, right? Speaking of building, let's jump over to Animoto real fast and take a look at how we can use a number of the tools and a process to help us create and structure any house, okay? Now, luckily for us, the simple shapes for homes and for architectural stuff is there's a natural starting point. What would that natural starting point from a tool be? What basic simple shape is a house? As a rectangle. Most houses are going to start off in a very planar shape like a rectangle, okay? However, what that doesn't give us, okay, if I just go in and let's just add in a rectangle here. Woo! There it goes. Okay? There are the walls of my house. Now, this allows us pretty quickly to start establishing the overall proportions, but, you know, we can do better than this, right? Because 9 times out of 10, a house isn't actually a rectangle. It's a pretty complex shape. You just look at the footprint of this room. On the surface, this feels just like a gigantic square, but when you start really deconstructing and looking at the details, you know, there's big bulkheads in the back, there's my office, there's a closet, you know, there's a big kind of, you know, landing spot over by the door. This is a, you know, while it's not a difficult shape to create, it's not a simple one either, okay? So the rectangle tools, in order to capture like this room with a rectangle, what would we need to do with a rectangle to be able to start crafting it in this shape? If you just look at the floor plan, the footprint of this room, what would we need more of? Or just edges, right? We need more edges so that we can start physically moving those points around to make a much complex surface. That gets pretty complex pretty quickly, right? Taking a cube and slicing it with a, you know, with the like loop slice or maybe even just the slice tool starts to add a tremendous amount of effort and energy into our process pretty early on. So let me introduce to you guys a better way to construct this, okay? I'm going to delete my cube, okay? And I'm going to look at my scene from the top. There we go. And we're going to return to our basic tool section. Now, inside of our basics tool section, last week we spent a lot of time talking about our curve tools, specifically the good old-fashioned Hermite curve, the B-spline curve. We even started talking briefly about the Bezier curve tool. However, if you look at this menu right here, bloop, left click and hold, the first one in the list is a really powerful tool for us. It's called the pen tool, okay? Now, the pen tool's sole purpose is to create geometry for us. It behaves and functions very similar to some of those curves tools, but the product is fundamentally different. It's always going to create an engon for us, a surface, okay? Drop the tool, and that's what we've got. This is a true piece of 3D geometry now. We can use this geometry however we want in the future going forward inside of our modeling pipeline, but the pen tool is always, always, always going to create some geometry for us. The same rules apply upon creation when we're working with the pen tool, okay? So you're always going to get those little tangent handles, those little control points, excuse me. While the tool is on, you can move these around, add new points, take them away, exactly the way that we were interfacing with the curve tools last week. However, we're going to generate geometry this time. Now, this is pretty cool because now I can go in and start maybe using the pen tool to flesh out a much more complex shape, like the interior of this room, right? As an example. So like the interior of this room, now I'm just going to do it according to my view to make it real simple. So this is going to be where the door is over there. Here's the wall for my office door. Now we're going back into the corner, okay? Go down a little bit. Bulkhead number 1, bulkhead number 2, and I'm doing this very poorly because I'm doing it fast. Here's the wall of windows. And this is going to be the wall where our chalkboard is, okay, or the projector screen. There it is. So I was able to very quickly flush out a basic simple shape with the pen tool pretty instantaneously, which is pretty nice, okay? However, in the context of 3D modeling, this isn't really going to give us, this is a good start, but we can do better, okay? What we really want if we were trying to create the footprint or the floor plan of a house or the interior of a room is a whole quad strip. I want to be able to punch in windows and punch in doors quickly and easily. Of course, I could continue to work with this inside of our 3D modeling pipeline by simply just extruding the shape up. Okay, there we go. Now, if I wanted, this is the inside, so I can just delete that polygon, flip the rest. Okay, welcome to our room, by the way. The proportions are not right. Nowhere close to being right. But we can do better than this, right? But the pen tool is going to give us that function. And this is one of the reasons why working inside of Moto is so great, because there's some really intelligent, strong additions to the pen tool that make it worth the price of entry into our playground. Let me show you specifically what I'm talking about. All right, so once again, I'm going to go over into the pen tool. I did, yeah. But check this out. Once again, I'm going to go back into the pen tool. However, this time, I'm going to look at its options down here at the bottom. Because the lovely developers down at the Foundry have given us a purpose-built set of tool options for the architectural world. It's called wall mode. It's pretty fantastic. Now, the default wall mode is on. Let's turn it to inner. And we have to give it a dimension, right? Does anyone know? I'm just going to create the floor plan of a house. Does anyone know the dimensions of an exterior wall on a house? I think it's 10 inches if my memory serves. Yeah, if you think about it, the outside of the wall of your house or your apartment is only really about that big. It's not that big, right? Yeah, because you got 2x4 framing, insulation, drywall, a number of other layers. And I think by code it's 10 inches, and then the interior walls are 6 inches. I think that's my memory. I could have that wrong, but let's just pretend that it's 10 inches. So we can go ahead and start inserting that value into this offset box. So I'm going to type 10 inches, okay? And unfortunately, the folks down at the live stream can't see this, but so if I wanted to denote feet in inches, apostrophe, right? Quotes.
So can we do this with everything in Moto in terms of like the scaling?
Yes.
So I'm thinking 3D printing wise, if you want to be able to model something so it's a specific size, you can use the feet and inch markings instead of the millimeters.
Absolutely. And if you want to work in this unit space exclusively, you can change the defaults. You can change the Moto preferences to be in feet and inches. These defaults are metric because it's better and perfect and so much easier to use. It drives me crazy that in good old America, we got to be so different that we got to be feet and inches, which is an absolute backwards, upside down, and horrible unit of measurement. It really is, especially when you think of metric, where everything is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just a 10 base. It's just, you know, I saw a great meme the other day. We had a government shutdown, a couple weeks ago, 3, 4 weeks ago, the government shut down for like, yeah, it shut down for like 24 hours, right? It was real quick. And the best meme popped up. It said, "Quick, the government shut down. Change everything to metric." It was great because metric is so far superior, right? Anyways, okay.
Aren't we like the only country that uses
No, there's like 3 others.
Yeah, it's like us in like a teeny tiny country in Africa, and then like an island in the South Pacific that uses feet and inches. Everywhere else in the world is metric, right? Except for us, because we're backwards and upside down, and we drive on the wrong side of the road. Yeah.
People drive on our side of the road.
No, I'm just being silly. I'm being silly. Okay. Anyways, we're going to use some real-world measurements and units here to start planning our walls out. As 3D modelers, okay, this is an excellent, excellent practice. The more we can build things to scale, the better we're going to understand the spatial relationships between all these parts and pieces, right? We're going to understand how big a wall is or where a window is going to need to be. We can start making, legitimate comparisons between what we're used to seeing in the real world and what we're building in the model, right? It's a good practice. And if we wanted to take it over into the 3D printing world, that unit of measurement is really important, right? We want to build in scale as much as we can. All right, so let's start looking at the magic of the pen tool. On the surface, it doesn't seem like it's pretty neat. You click once, you click twice. Oh, that's cool. Okay. Now it's created a rectangle that is 10 inches in diameter. Okay. And if we continue clicking, you can see that the computer is going through and doing all the hard work for us and creating all the mitered angles for us. It's creating a lovely quad strip. Okay. While the tool is still active, I can just grab these points, move them around. Yeah, look at that. And that's pretty neat. That allows us to very quickly prototype a floor plan without too much energy, especially when we pair it to a real-world system of scale, a real-world understanding of dimensions. So right now, that's 10 inches. Okay. If I want, maybe my architect comes in and says, "Oh, Pat, it's not supposed to be 10 inches. It's supposed to be 12 inches. Well, while the tool is still on and active, I can just say 12 inches. And once I hit return, whoop, everything grows a little bit. Okay? So we're building with scale, to scale, initially, which is pretty exciting. Now, there's some options inside of the wall mode that I want you, at the very least, to be aware of. Over in the lab, often people make these changes, so it's important that we understand what the changes are so we can change them back. With the wall mode of inner, I want you to look very, very carefully as to where all the control points are and how the computer has drawn that edge in the polygon. Okay? The control points are on the inside of the wall. Once we change our options from inner to outer, bloop. Okay, now the control points are on the outside of the wall. And then naturally with the wall mode of both sides, now we have, now they're in the middle. Now, with both sides, is this wall 12 inches in diameter? No. How big is it? Yeah, it's 24 inches in diameter. So keep that in mind. Keep that in mind. I almost always, and I think this is just because it's the first option on the list, keep my option set to inner. Makes it a little bit easier. Okay? In addition, we also have to follow, and if I wanted this to be a closed shape in here, what would I need to change inside of my tool options to close it all up? Yeah, that close option. Yep, right here, this guy. So the moment I turn that on, Moto will take care of the rest and draw a polygon from the first and last control surface on your row. Hold on a sec. Yep.
How can you deactivate it?
Deactivate it? Just hit the space bar, drop the tool.
Okay, and right now you need to add something again. How can you?
So this is the big difference between the pen tool and the curve tools that we saw last week, right? With the curve tools, you can just go back in and select the curve and edit them, to your heart's content. With the pen tool, the moment that you drop the tool, now these are just straight up polygons. They aren't special. The computer doesn't look at them different. The computer doesn't understand after we've dropped the tool that there's some sort of history associated with these surfaces. So these are polygons just like any other polygon now. Okay? I can move around. Okay? I can do whatever I want with them. Shoot, I could even look at this from perspective. I can grab just one edge and move it up. So we have to be careful with it going forward. Okay? Well, the curve tools, you can adjust a curve at any time within inside of our modeling pot. You can mess with the curve moments right until you hit render, right? But with this, the moment that you drop the tool, you lose all history to the tool properties, okay? Because what happens is that it just transforms it into straight up polygons at this point. Moto doesn't have tool history like other apps have, so that once you're done with the tool, you kind of say goodbye to all those properties. Bingo. Yeah. As soon as you dismiss the tool, you dismiss all of its properties from being remembered inside of the modeling tool set. Okay. All right. So this is a good start. I'm liking this, but we can do better, right? Because last time I checked, there are some like 90-degree corners. There are some straight edges on floor plans for houses. So we need to look at how we can add a new layer of accuracy into the model that we're creating. And luckily for us, the snapping engine inside of Moto is going to give us that accuracy. Before we go too much further, I think now is probably a good time to change my unit of measurement from metric to good old English, So if you go into the global Moto preferences, okay, these are all your application preferences. You'll find it, where's the unit section? Right down to the input category, units, right there, okay? And at the top here, we don't want the unit system to be standard imperial. We want English. That way everything's in feet and inches, okay? And now every tool is going to be read and communicated to you as feet and inches, okay? A little bit easier to use, especially if you're comfortable working with feet and inches. All right. So once again, I'm going to look at my scene from the top, and I'm going to start using the pen tool to block out a quick floor plan for my house. However, like I said a minute ago, I need to ensure that I'm making some 90-degree corners, okay, as best I can, maybe some straight edges in there. So our snapping engine is going to help us out in that regard. The snapping engine is a global snapping tool. It's a global snap. It's that guy right there, okay? Meaning that this is going to, when it's on, it's going to influence every tool that we use, right? So the move tool, the rotate tool, scale, bevel, any of our deformation tools are going to be influenced by the snapping engine. It's a global snapping engine. It's a really good snapping engine. I like it a lot. It's honestly better than most out there. We turn it on two ways. Just click on the button. That works pretty well. You can also hit the X key. X is in xylophone or X-ray. And that will turn our snapping engine on and off. In addition, if we hold down the Option key on our keyboard, you can see that there are a whole series of nested snapping options inside the button itself, which will allow us to change what we're snapping to. We can snap to grids, we can snap to existing vertices, or any other component inside of our three-dimensional scene. If we cruise down to the bottom of this list, check it out. There's actually some good additions to our snap engine that's really important for what we're trying to do in this moment, like world axis snap. So it's going to snap according to the current or global orientation of the XYZ axis. I also like maybe some straight lines. That'd be helpful. And I love this, right angle snaps, to ensure that certain corners are going to be perfectly perpendicular to each other. All right. And I'm going to turn off grid just for the time being, because these three are going to get us where I need to go pretty quickly. All right. Let's turn on our snapping engine and once again refire the pen tool. Just going to make sure that wall mode's on. I'll put this back to 10 inches. And now I'm going to start designing my floor plan. All right, so there's that. I'll make a back wall of my house. And check it out. With those snaps on, I know it's kind of hard to see on the projector. Let's see if I can do my magic here. Nope. With me all zoomed in. All right. Can you guys see the little, on the projector, can you see that little square that pops into the corner? If this was a geometry class, what would that little square mean? Right angle, yeah. So we are getting that right angle snap in there as well, which is pretty cool, okay? With the snapping tools on, you'll feel, it kind of locking into different angles. Pay attention to the feedback the tool is giving you. It will tell you what it's snapping to and the right angles that we're creating. So with that in mind, I can very quickly come in here and formulate a pretty good looking house, okay? I think for me, I want to have an interesting shape here at what will be the door. Yeah, maybe I have a cool little angle over here. This will be where my front door is. I want to make this an $8,000 studio loft apartment in the mean streets of San Francisco, because that's pretty much what it costs to live in San Francisco these days. Anyways, so I'm going to have a little, maybe this will be my porch, have a little barbecue area. Got to have a place to barbecue, right? Anyways, okay. So this is looking pretty good. And I'll have my front door over here at this weird angle just to start to illustrate another idea here going forward in the future. So I'm pretty happy with that. That's my floor plan for my house, okay? At this point, I usually do a good double check, make sure that I'm ready to rock and roll before I drop the tool. I'm happy with the outside of my walls. And there it is. There's the floor plan for my wickedly simple house, okay? Now that we have the floor plan, the footprint for our house, what's the next natural step in here? What do you think? Yeah, now we have to make physically some walls out of it. So we can either extrude or bevel. Now what's the difference between an extrusion and a bevel? Because on the surface they do something very, very similar to each other.
The bevel adds extra geometry, the extrude just moves the top.
Flip it and you have it right. The bevel tool, okay, if I was to fire off bevel, of course naturally I could raise up the walls like that. If I drop the tool and look at the bottom, it's hollow, okay? I'll turn off the grid so you guys can see a little bit more what I'm talking about, okay? It's hollow underneath. In contrast, the extrude tool, Shift X, is going to create geometry down there at the bottom. Okay. Now before I drop the extrude tool here, let's look at some values. How high should my ceilings be? That's a good question. 10, 12 feet. I think it's a natural place. We're lucky, very happy to have such high ceilings in here. These are probably like 20-foot ceilings, which is kind of cool. If you look at the values that we can place over inside of our channel boxes here, we can actually extrude this to the appropriate height if we wanted to. When we're working in real-world scale units, believe it or not, there's a lot of details that we can add pretty quickly. Okay, so there's 12 feet. Hit the return key, and now I know numerically, beyond any reasonable doubt, that those walls are exactly 12 feet up from their starting position. Okay, that's a 12-foot wall. Awesome. Okay, I'm building Pat's barbecue shack over here because it's not a very big place. Okay. All right, so now with the walls constructed, let's look at maybe what potentially could be next, okay? Now, I think I want, for Pat's Barbecue Shack, a whole bunch of windows. I like a lot of natural light, so I want to have a whole bunch of windows around my house, and maybe a big bay window in the back so I can see out into my barbecue to make sure I'm not burning down the neighborhood, which I have almost done, by the way, barbecuing one time. It's one of those moments where you turn your back for 10 seconds and then chaos and just kind of, anyways. All right. Now, if we look at windows, and if you look around our classroom, of course we have a lovely bank of windows here. We have some windows over in my office, okay? If you look at these windows over here, what can you tell me about their size in comparison to each other?
Same size.
They're the same size, right? Most windows, believe it or not, are going to be pretty uniform in size, right? Especially in the context of a given house. So how are we going to add in some geometry on my house that's uniform in size? Good question, right? Let's think through some of the potential answers to the question. Now, for a window, I'm going to need both, vertical and horizontal slices in the mesh to create some openings. How could I do that? And specifically, someone else said it, loop slice. Loop slice is a great tool. If you think about how we can apply loop slice in a moment like this, loop slice is going to very quickly allow us to, I'll just run it, loop slice, count of 2, mode of symmetry. Loop slice is going to allow us to establish the overall height of our windows pretty quickly. But how are we going to create the width of our windows? Now remember, I want all of these windows to be identical, as close as I can, right? How can I do that with this kind of process? Now we could go in if we wanted to and do some additional loop slices in here, but I think you'll probably start to see pretty quickly the problem that we're going to have, right? I could loop slice here, maybe even just a count of 1, mode of free. Okay, so there's the width of one window. And of course, doing the first one is easy, but how are we going to replicate that shape in another slice? Yeah, you can't copy paste a slice, okay? You can't, not easily, not quickly, okay? So we need to have a better tool here. Say again?
What
create a new polygon. I like the way you're thinking. We need to have a better tool that maybe uses geometry as a slicing tool for us, right? That way we can create one window and then slice our mesh based off of that piece of geometry. It's a cool idea, right? This is called Booleans, where it's geometry slicing other geometry. And it's really easy to set up here in Moto, and it's a powerful, powerful addition to our 3D modeling pipeline. I'm going to hit undo a couple of stages to get rid of all of those slices. There we go. And now what I'm going to do is create some windows. Okay. Now luckily for us, a window is a pretty defined shape. Let's see, how big is my window going to be? This is the size. Right now it's 9 feet by 13 feet. There's a gigantic window. A window is definitely not going to be that big. Let's make it 3 by 4. Okay, 3 feet wide, about 4 feet tall. That's probably pretty close to a standard window size. So it's going to be 3 feet by 4 feet, 36 inches. Yeah. Remember, okay, apostrophe is feet, open quotes, inches, okay? From millimeters over to feet and inches? Yeah. You can do it inside of your global Moto preferences, up at the top of the screen, Moto preferences, and it's in the units section in that list. All right. So there it is. There's my window. Yeah, that's better. That's a little bit more representative to the shape that I want, right? So now, this needs to be 3D geometry, because what we're creating here in every sense is kind of like a cookie cutter, okay? Think of our walls like a gigantic, kind of laid out piece of dough, and now this is a snowflake cookie cutter to make snowflake cookies, right? So it needs to be 3D geometry. It can't exclusively be 2D geometry as it is now. So let's just extrude this shape out and give it some depth. Now the size of the, in this particular case, the length of our cookie cutter does not matter, okay? There we go. And now we can copy and paste it. You got it, right, because now we have a system in here that we can use to begin to create our windows. Okay, now I'm eyeballing it. I could bring it down exactly 4 feet from the ceiling. I could do that pretty quickly. More on that in a second. I'm just going to pretend that this is where I want my windows to go. Okay, so this is where my front door is going to be. I want some windows up here, maybe over here, maybe a big one in the back. And luckily for us, this Boolean system allows us to work quickly and get the details that we're after. Since geometry is going to be slicing geometry, we can have as many of these cookie cutters inside of our scene at once. Okay, so let's use maybe some cloning to make some more windows. Okay, so I'm going to go over into my duplication collection of tools, and I'm just going to run a clone. Okay, now how many of these do I want? Let's see, I really don't know. Maybe 3 along this window. There we go. That's pretty good. Something like that. I like that very much. Okay. Now I want to have the same number of windows or so on this side. So I'm just going to copy paste. Fire off, or here's a better way of doing it. If you fire off the move tool, then hold down Control and Shift. You can drag out a copy. There we go. You could also do that for all 3 if you'd like. Control Shift, drag out a new copy. The only thing that we need here to ensure is that our geometry goes through our walls. Okay? In order for Booleans to work, the cutting geometry has to completely go through the thing that we're trying to cut. Okay? And I think for Pat's Barbecue Shack over here, oh, these are actually going the wrong way. That's okay. Actually, I'll leave these here, and because remember, this is going to be the front door. This is the front side of the house. Let's do it one more time. However, these I'm going to rotate 90 degrees. There we go. Let's figure out what the distance is going to be. I don't know. Let's just pretend. Let's run clone. Something like that. There it is. It's a lot of windows. Like I said, I want my, There we go. So there's going to be the basics of my house. Now, I want to have a big bay window over here by my little kitchen sink because it's always serene to have, look out into the world as you stand there washing your dishes, right? Yeah, so I'll get rid of that one. So I'll just have one gigantic window here in the back, okay? And then maybe if I have time today, I'll slice in a door or something. But there are all my windows, okay? Now, it looks kind of silly and odd at the moment, but we're going to make it better. So in order for the Booleans to work, we need to separate all of our geometry onto different mesh items, okay? We need to have the walls on one mesh item and all the geometry that's going to cut the walls on its own mesh item. So we need to start separating these things out. So let's do some cleanup in our scene to start this working. Okay. Let's just rename this mesh item to walls. And I'm going to hit the N key, N for new, to create a new mesh item. And I'm going to call this one cookie cutter. Okay. So I'm going to put all of my windows on the cookie cutter mesh item. How could I do this pretty quickly? And I'm gonna say cut and paste. Cut and paste. Yeah. Cut and paste is going to give me the result that I want. And shoot, instead of selecting a whole bunch of windows, I'm just going to select the walls and then invert my selection to grab all the windows. Okay. Now, edit, cut. So invert, it's the open braces or open brackets key. It's the key that's right next to the P key. P is in Papa on your keyboard. So edit, cut. I'll go to my cookie cutter mesh item, edit, paste it in. Cool. Now we have them all separated out. Once they're separate on their own mesh items, we have to be very aware of what item is currently active inside of our Moto scene. Okay? Because Moto looks at this active item and kind of everything is cut inside of it, right? I want to have my walls be the active item. So just clicking on it, selecting it, makes it the active foreground item inside of our modeling toolkit. Okay? Everything that's deselected or in the background, in finger quotes, as the developers would say, are going to be evaluated when we run the Boolean operations. So we've got to be careful. If we have other items inside of our scene that we don't want to serve as a cookie cutter, we've got to turn the visibility of those things off. Because whatever is visible and unselected will be evaluated by the Boolean engine. So we've got to be careful. All right, and this is what it looks like. I'm pretty happy with this. Now, let's run the Boolean. And this is where the magic happens. We find our Boolean tools in a couple different places, but the easy place to go is under the Geometry pull-down menu. And it's way down here at the bottom. Okay? And there they all are. We have 3 Boolean tools. Okay? My favorite is Solid Drill. I like Solid Drill because it gives me the most options going forward. I'm in control of the next step. I never liked the computer doing magic for me, right? I want to be able to tell the computer how I want to advance in through my modeling sequence. So Solid Drill gives me the most options going forward. Let's fire it off. You'll get a little popover. If you look at this popover, there's a couple options in here that we need to look at. Specifically, driving mesh. This is the mesh that has our cookie cutter on it. It's currently set to background, which is what we want. Okay? We want the background mesh items, the unselected items in our item list, to cut our geometry. Now the operation, this is how it's going to cut our geometry, and I'm going to choose slice. Because I want it to slice. I want to physically run a slice operation. All right? And then we hit OK. Blue. Wonderful. If you look down here, you can see the computer has taken those pieces of geometry and it's sliced my walls exactly where that geo resides, which is pretty neat. Let's turn off my cookie cutter mesh item and look at the product of this. Since our geometry went from the outside and all the way through our walls, it's actually done both sides of the wall at the exact same time, which is very, very handy. You're not going to get that with loop slice, okay? Now that I have this in tow, I'm in control of what I want to do next. Yeah?
So can I just reiterate real quick?
Yeah.
To make the windows, you made cubes, go through the walls. You made them different mesh than the walls, and then you made them inverse, right? Or something like that?
No, when I was inverting my selection, just to very quickly grab the windows. Okay, yeah, we don't have to invert them.
Okay, and then once everything's ready, you go to Boolean, solve drill, background, and slice.
You got it. You got it. And if you want to see, a visual kind of representation of that sequence, just look at the live stream too. That's going to be helpful. All right. So now I have a little bit of a challenge in front of me. I got to start making some windows. Okay. Now, luckily for us, I'm not going to do all of these because it takes a couple minutes, and admittedly, it's like watching paint dry. But check it out. Here's a good little trick. If I wanted to make a window here, I physically need to create an opening. The more we can behave like a construction worker, the easier 3D modeling becomes. If you've ever done any sort of construction, if you watch someone build a house, they frame in the openings of the windows first, right? Then, once they have a hole in the wall, what do? They put a window in, right? Because windows come as complete units from the factory or from Home Depot, right? And they shim out the window to make sure that it's square inside the box, right? And then they waterproof it, weather seal it, and they put trim around the window, right? So there's actually a couple different layers that goes into the creation of the windows. But the first thing that they start with is an opening in the wall, right? So I want to start with an opening in the wall, and then I'll create a window that'll go in that opening, just like they would out in the real world. So how could I create an opening in my wall to start this window making process? Yeah, you got it. And I'm actually going to delete the outside and the inside at the exact same time. Delete, bye-bye. Now I need some geometry in here. I can't have it just be open here in the inside. We can bridge the edges, absolutely. So I can double-click, shift, double-click. I can run my bridge tool. We're on our way. Okay? That works. That's a wonderful way of closing the gap and making the opening for the window. Here's an alternative way. This is going to save you some clicks. Check this action out. Again, I'm going to start with that and the inside one. But now, check it out. I'm just going to run bridge. Bloop, bloop. Oh, of course, it's not going to do it right now. Let's try that again. Bridge. Oh, I hit mirror. I didn't hit bridge last time. I hit mirror because I'm a dork. There we go. Oh, nope, still not doing it. Why are you not doing it? You should be doing it. No, you can do it with polygons. Let's try it on this one just to make sure. No, I've done this a million times. Bridge, 2 polygons, and it's not working today. There we go. Remove polygons was not enabled. Yeah, when remove polygons is on, then it just closes the gap for us, which is pretty neat. Let's do it again. Run the bridge tool. Make sure that remove polygons is on. Bloop. And it saves us a couple extra steps. All right. Unfortunately, this isn't something that we can do at the same time. So you have to do one. Let's see. Usually this fails pretty quickly. Yeah, and it failed pretty quickly. So we'll just do one window at a time. But luckily, it goes pretty fast. All right. And that's all I'm going to do. Aha! Now it's starting to look a little bit like a house. It's got some windows in there, which I'm pretty digging. However, we have one gigantic problem. What's missing? I like the idea that we paint with a broad brushstroke. Let's figure out all the major, big sculptural details first, and then we can zero in and get all the fine detail, like trim, windows, doorknobs, things like that. What is the massive missing piece here? Ceilings and roofs, right? We'll get to the flooring here in a second. That's actually a whole lot easier than you guys probably imagine it is at the moment. But we need a roof, right? We've got to have a roof on our house. So let's talk about how we can construct our roof quickly. Now I'm going to just make a very, very simple roof, okay? Here's a simple, kind of simple little pitch on it, okay? What basic simple shape is a roof? Basic simple shape. It's a plane, yeah. It's a square. It's basically a plane that's been pitched up a little bit, okay? And then, we have symmetrical halves of our roof. And at times, it can get really complex, right? But its basic, simple shape is a rectangle, right? How do they make roofs? What materials do they make roofs out of? I spent a summer as a roofer. It was the worst summer of my life. I hated every moment of that job, right? It was one of those summer jobs that at the conclusion of the summer, I can say, yep, I am not a roofer. I hated that job, right? It was hot, and everything was heavy. I always felt like I was moments from death, from falling off the roofs, right? I just generally didn't like it, right? However, I learned a tremendous amount about roofing. If you were to describe the materials that are used to create a roof, what shape are they? The rectangles, pieces of plywood. If you think about it, and this is the scary thing about roofs, your roof is only about that thick. There's not a whole lot that goes on in your roof. It's about inch plywood. Then there's the teeniest tiny little bit of vapor barrier, maybe a waterproof sheathing on top of it that's very, very thin, literally paper thin, right? The thing that's keeping the water out is a paper thin membrane, okay? Anyways. And then you have roof tiles on top of that really try to get the water away from the plywood. Yeah, it's only about that big, and for the majority of it, it's just rectangular pieces of plywood with some tiles or, some roof tiles on top of that, okay? So it's very flat, obviously, most roofs. So it makes sense for us as 3D modelers to start with a flat shape like a square, okay? Now, I'm going to make my roof really chunky just so it's really easy for you guys to see the sequence that I'm going through. Naturally, a roof, and I'm just going to use the square tool, okay? Naturally, the roof is not 30 inches big, okay, thick, right? It's only like 6 inches thick, probably at its, if you compare it, it's just really difficult to see, so I think just for today, I'll make it nice and big so you guys can see what's going on. That was maybe a little too big. Well, that's a big roof, okay. I was making it kind of a big chunky square so we can see what's going on. All right. So that's a roof. Okay. Now I want my roof to be generally symmetrical. I want the left side of the house, left side of my roof to be identical to the right side of the house. Okay. So maybe at this point I should start looking at how I've constructed my model itself and start centering it along the x-axis. Now I'm not going to do center all because that would move the house down below the middle of the y-axis. I don't want that. I just want to center it along the x-axis, okay? So that the center of the entire shape is at the center of the x-axis, which will give me a great mirror point for my roof, okay? All right. So now, let's start exploring this roof a little bit, okay? Here's a great little trick for roofs, okay? Start with a rectangle, then rotate it. Now, there are some legit math that goes into establishing the pitch of roofs, okay? I'm not going to go through that right now. It would bore you guys, and it would instantly put you to sleep. So we're just going to do this visually right now. We're going to make a cool, fun, pitched roof, okay? However, and what I'm looking at right now is the pitch of the roof from the middle of the x-axis, which is right here, all the way down over here. So this is going to be the ridge line of my roof, right in here. So this is all waste. This is going to be chaff here in a second, okay? Let's start creating the actual ridge line itself, and this is where our snapping tools come in. How can I very quickly slice right around the center of the x-axis? Slice tool, absolutely, right? So I'm going to turn on, and especially when you pair it with the snapping engine, turn on my snapping engine, hold down the Option key to look at what I'm snapping to, and I want to snap to the grid, okay? I'm going to turn off world axis, straight line, and right angle for the time being. And now, Shift-C to run on the snap tool, and there it goes. Okay? Now, on the surface, a lot of folks, this is what they'll do. Okay? But if you're not careful with the slice tool, you can actually slice your interior shapes too. Remember, the slice tool is like a laser. Okay? Wherever that laser touches, it's going to slice your mesh. How can we influence any tool inside of our scene? If I only want to influence that one polygon, just select it. Yeah, because now I can be as sloppy as I want because I know that the tool is only going to influence what's selected. So once again, Shift-C to run slice, draw out a straight line, and now I've just sliced that one shape. So if you look at our pitch of the roof, This is waste, okay? We don't need that anymore, so I'm going to delete it. And now I'm going to spend all of my energy with this guy right here. Now, I'm pretty happy with the overall shape of my roof. This is pretty cool, okay? One of the big benefits that we get from this process is that we get a lovely kind of little right angle down over here. Now, depending on who's crafted your roof, this is actually going to be a right angle. Some people go in and they do a, excuse me, there we go. They do a straight cut like that, okay? So that as it comes, as the water comes off the roof, it's going to follow the surface that's on. It's going to go straight down, okay? Some roofs are left like this, but given how close they are, the water's going to come down, it's going to run straight down, but then it's going to go back in towards your house a little bit. So anyways, it's a small little detail, but it's a good one nonetheless. Now, I have some challenges in here because I really don't like my overhang. This is not where I want it to be. This is only, I don't like, I want to be able to push the eaves of my house, my roof out a little bit further away from my house, okay? Now, so big picture idea, I want this distance in here to be bigger, okay? Now, if I just fire off the move tool, turn off my snap engine, and start doing this, what am I doing? I'm messing up the pitch of my roof, right? Which is not what I want at all. I just want to extend. See how it messes with the pitch? Okay? I don't like that. I don't want that. Okay? Now what I want to do is that I want to move this selected edge along this angle. I don't know what that angle is. I really don't. I'm going to let the computer figure it out for me. This is a new action center. We've been looking a lot about action centers over the past couple weeks. Last week we talked a lot about the origin action center. As you remember, our action centers determine the placement of our tool handles inside of our three-dimensional scene, right? With the action centers turned off, that's the placement of our tool handles. They follow the global orientation of our XYZ axes. I don't want my tool handles to be, up, down, left, right, according to our global orientation of our axes. I want them to match that angle precisely. So let me show you a great tool, or a great action center. I use it all the time. If we go up into our action center pull-down list, what we're going towards is the element action center. Now, the element action center is going to require us to click on an existing 3D element to determine the orientation of our tool handles. Check this out. Okay? So I've turned on the element action center. I fire off the move tool, and this is where people usually begin to panic because they don't see the tool handles yet. We got to click on an existing edge or surface. See how it goes blue? Bloop. And now my tool handles are perfectly matched to the angle of the thing that I selected on. Okay? And I'm free to move that shape around, and now it's not going to change the pitch of the roof. Okay? I can do whatever I want, which is pretty cool. Let's put it somewhere right in there. I'm pretty happy with that. And I'll turn my action centers back off. All right, so I got one half of my roof. Now I need the other half of my roof. What's my next step? Mirror. Okay? Now the mirroring tool set is pretty easy. Of course, we're going to start with a selection of our kind of half roof. We could change our action center to origin if we want, but do we need to? Not for this. What could we pair the mirror tool with to ensure that we're duplicating this shape precisely where we want it to be? Snapping engine. This time, I'm not going to do grid snapping. I want to do vertex snapping. Turn off grid. Okay? With vertex snapping on, I can set my mirror tool handles to snap, boom, to that vert, the one that's right there. Okay? Let's do it real fast. It's pretty fun. Grab my roof. I want to go to my duplication collection of tools. Of course, naturally, I'm going to run mirror. Where I select inside the scene determines where the mirror's center point resides. And this is the cool thing about Moto, and I wish every app did this. It gives you a snap highlight. Okay? That's the vert that I'm going to snap to, and where my tool handles for my mirror command are going to be placed. Bloop. Now I'm mirroring along the wrong axes. If I mirror along the x-axis, I'll get the result that I'm after. And now I have a symmetrical roof. Ah, awesome. Left side and a right side, that's the same. They're all one piece too, which is which makes it pretty cool. Now this is a pretty simple roof. Let's make it a 3D roof now. I want to move this to the foreground. Oops. There we go. Somewhere, I don't know, right around there. There will do. And I'm just going to do a simple extrusion to give it some depth. Now I want to have a big overhang here on the back. Maybe I can create some pillars for Pat's barbecue hut. There we go. We're on our way. It's looking good. However, what's the problem with this? Yeah, it's not connected. I have the world's best or worst air conditioning system, right?
It's just shade.
Huh? It's just shade, right? We need the top of my walls to go into the roof line itself. We need to fill the opening in there. How in the world are we going to do that? You got it. So we can move the walls. I'll select the top row of my walls, move them up. Okay, that's not what I want because I need to have the shape of my walls match the pitch of my roof. And look at that. That's pretty intense in there. How am I going to do that? Bridge. Snap to the verts would be, that's a step in the right direction. Booleans. Because remember, with Booleans, we can use existing geometry to slice other geometry. Okay? So now what I want to do is not slice in windows. I want to slice in a roof line on my walls, right? I want the shape and the current placement of my roof to slice the walls of my house. Okay? Let's check out that. It's pretty easy. It's going to follow the exact same process that we did before. Now, we have to remember that in order for this to work, the walls need to be going up above my roof line, just like the windows did. The windows went all the way through the mesh, okay? So my walls are going all the way through my roof, which is what I want. With that in mind, I'm going to grab my roof, edit, cut, take it back over here to my cookie cutter layer, edit, paste, okay? I don't want my windows anymore, so I'm going to invert my selection and just delete those polygons. Okay. Now, which of these two mesh items do I need to have selective and active in order for the Boolean tools to do their job? The walls. You got it. So the cookie cutter is always going to be in the background. It's visible, but unselected in our item list. Okay. Where do I find my Boolean tools? Geometry, you got it. So they're in the geometry pull-down menu, and it's down here towards the bottom. And I'm going to run solid drill, just like I did before. Okay? I like my slice operation. I'll let you guys explore the others. They're pretty cool. Okay? These are not like, no-fly zones for us. I mean, you can use these. Slice just gives me the most control going forward. Okay? Bloop. And now, I've sliced in a roof line. What am I going to do with all this jazz up here at the top? Delete it. Don't need it anymore. Shift up arrow. I'm going to delete all the way down to there. Delete. And then I'll return to my cookie cutter layer and then cut and paste back in. And now it matches perfectly. Now it's beginning to feel a little bit more like a wall. Like the walls and the roof kind of live together in the same space. This is the power of Booleans. We're using geometry to slice geometry, right? I could probably go in and figure out all the angles and have, move each individual verts, but that's just giving me a headache thinking about it, right? Say again? This is just easier to do this, right? It's easier to do this, which is pretty cool. All right, so this is looking pretty great. Now that we have the overall shape captured, let's spend some time talking about maybe one of these windows, okay? Because I want to have some compelling detail in there. However, I have a lot of windows, and I'm not going to model this thing, I want to do this intelligently, right? I don't want to have to model each window by hand. That's just like, no, that's not going to happen. I'm not doing that, right? I want to be a smart modeler, not a modeler that works crazy hard. So maybe if knowing that all of my windows are the exact same size, What if I made one window and all of its appropriate trim? And then I can duplicate that into all the window frames. With the power of our snapping engine, we can get through this thing pretty quickly. Let me show you what I'm talking about. The snap engine inside of Moto is something that we should use at every single level because it really does give us a tremendous amount of power and flexibility inside of our modeling process. Okay. All right. So first things first, I need to create a window. Okay. I'm going to grab, I'm just going to do a loop select on that window there. And let's see. Yeah. All right. Yeah, I'm going to just bevel this in. Actually, I'll just do a shift first. Okay. Hold down the shift, click again, do the red handle. Now I'm going to start creating shift, click again. Oops, went the wrong way. There we go. Now we're starting to create a simple little frame. Now, folks get really geeky about this. They can get really geeky about this, okay? With actual dimensions, I mean, we can say, okay, that's going to be, you know, an inch or 1.5 inches, okay? Now I know that dimension down there is exactly 1.5, and all. I mean, we can get pretty nerdy about this pretty quickly, but I'm just going to do it visually because I'm running out of time. Shift click again, and I'm going to do that entire thing, shift click, one more time. Something like that, just to create a believable window. Okay. Yeah, that's looking pretty good. I'm happy with that. So basically, here, let's add one more thing. I want to start. Let's do this. I'm going to loop select, shift up arrow. That's the structure that I now want to copy and paste into each window. Okay? So I want to do Command X to cut, and then Command V just to paste it right back into its spot, right? Now that gives me a piece that I can just double click on and move around. Okay? That's cool. Here's a great trick. This is an old school trick, by the way. If I wanted to create a specific, like a piece of glass in our windows, okay? We've been doing this for a generation, okay? Just do loop slice, count of 2, mode of symmetry, okay? And now we're just picking out the dimensions of the actual glass itself, maybe something like that, okay? If you grab each individual loop, hit the P key, okay? Creates a piece of glass, or what we could tag as glass in our material properties. Same with the outside. Boop. Okay. Need to make sure that I actually grabbed it. Hide that one. P. Yep. This one is being created in the opposite direction, so I'll hit the F key to flip it. Unhide. Now I have, an outside pane of glass and an inside pane of glass. This will help you create like really cool refractions in your glass. Look like it's actually supposed to. Most glass windows are double pane. There's a small void in between two pieces of glass for insulation, in sound barrier. Anyways, okay. So now I have one piece, but I really like some trim. Like I really want some trim. Okay, a casing that goes around the window itself. Okay, this in every sense kind of simulates the construction practice. If I hide it, there's the opening for our window. Something that we'd frame in. There's the window itself, okay? But now I need to trim it out and create a casing so you don't see, kind of like if we were on this is a brick building, so it's a little bit different, but there should be some sort of trim or casing that goes around it. But if you go home and start looking at windows, there's a piece of trim that goes around the outside. Well, we can very quickly, and I mean very quickly, create this with our modeling tool set. Now, what basic shape is a piece of trim? If you look at my office windows over there, there's trim that goes around the openings of the window. What basic shape is it? Rectangle. It's a square. It's a rectangle, right? Now, I could go in and create a whole bunch of rectangles using like the cube tool. However, let's go back to where we started today, the pen tool. Because if you think about the pen tool, especially with the wall mode enabled, what is it fundamentally going to create for us? Rectangles, right? That's what it does. Let's use that and pair it with maybe, some vertex snapping, and we'll get a really good result. Okay, so I'm going to turn on my snapping engine once again. Triple check, Option key, to make sure I'm doing some vertex snapping, which is what I want. And now, grab the good old pen tool. See how my snapping engine wants to snap right there? So I'm going to let it snap. Just going to go around the corners. Now, I don't want close on, and it certainly is way too big. Way too big. That's some gigantic trim, right? And I also want to make sure that merge is off because I don't want these verts to be glued together to any vert behind it. Okay, I want this to be a separate piece. Okay, this gives me some flexibility. I think I'll have my trim be 2 inches in width. There it is. I like it. I drop the tool, fire off the bevel tool. Let's bring this out. Yeah, 3/4 of an inch, that's fine. That's probably good enough for what I'm wanting. Oops.
How did you make the trim? Was it with the pen tool?
Pen tool. You got it. There it is. Okay, there's the outside trim. Now I need a sill. Okay, a little part that goes underneath the exterior window. Do the exact same thing. Now the sill goes from the outside trim to the outside trim. However, if we just do the exact same thing, wall mode, snap to there, to there. Of course, it's going the wrong way. Is there any way that I could change that? I don't want it to go up. I want it to go down.
Wall mode outer?
Yeah, let's try this. Wall mode outer. Now it's going down. I'll leave the dimension at 2 inches, and I'll drop the tool. And then once again, I'll bevel this guy out. Something, I don't know, 1.5 inches, why not? 1.5 inches, okay. That looks a little small, but now I have that bottom bit. You can even, if you want, if you really wanted to get crazy with the accuracy, if you look at sills, they're never flat. What shape are they? Does anyone know? Yeah, a little rounded, and there's an angle there. Why is there an angle there? For rain, yeah. You don't want the rain to collect on your windowsill. But now I've created this really ugly void in here. How can I solve that? Could. Let's use the power of our snapping tool, because really what I want is I want that vert in the exact same height as that corner over here. So I'll turn on my snapping engine. Remember the snap tools. That's good enough. Okay. You could do it by eye. There's another snap option in here. Where is it? Intersection. Sometimes this works really well because now it will snap at the intersection point, and there it did. Yep. I don't have to think about it. Let the computer do all the heavy lifting for me. Come on. There it is. Done. Yeah, I know. Snapping's awesome. Right? Rock and roll for snapping. Okay, so one window done. Now I've got to have a bunch of these. Okay? Oh, a bunch of these. But luckily for us, that gets pretty easy pretty quickly if we start using the power of our snapping toolkit. Okay? I don't want an intersect snap anymore. I want like vertex snapping, because check this out. This is actually pretty cool. I'm just going to select all the pieces that I need to copy, which is just those 3. There we go. And now I'm going to start moving them over. Oops, sorry, I forgot to hold down the Control and Shift keys. Okay. All right, so now what I want to do here, let's see. The easiest way to snap this, in all honesty, and I'm going to go back in time a couple steps, I apologize, is I'm going to snap the windows or copy the windows, and then I'll come back and do the frames because that'll be fast and real easy. So let's make a copy of the window. Now we'll turn on my snapping tools. Oops, excuse me. And if I run the move tool, I want to snap to that location right there. Okay? And this is the power of having action centers that we can place anywhere we want on the model. Okay? Because I can tell the computer I want to snap from that location to right there. Okay? Make another copy, Control Spacebar, Control Shift, excuse me, and snap from there into the window. Let's do it one more time. From there, from that corner into the window. Okay? That part's done. Now let's do the trim. Same idea. Control Shift to make a copy of it. But now I want to snap from the inside edge, that one, to the outside edge of my window. From there, I'm just going to drag over, boop, snaps. And within a couple seconds here, totally detailed out this model. There we go. Starting to look pretty good. Okay. Pretty rad, huh? The snapping engine inside of Moto is worth the price of admission. It's pretty fantastic. Believe it or not, as simple as it sounds, not every application has this powerful of a snapping engine. This gives us the level of accuracy that we need to be able to produce architectural models, okay? Or just models, accurate models in general. Pretty fantastic, okay? So use the snapping tools, okay? They are extraordinarily helpful. I love the snapping tools, okay? Now, once you have your model done, of course, we need to start thinking about the render itself, okay? So let's go over to our render layout just for a second and start exploring, hit the A key to autofit, start exploring how we're going to render our object. Because as I mentioned, a good architectural render is more than just the house itself. Because I've just done a simple composition here, very simple composition, framing my house so that I'm getting a majority of the house in the render camera itself. And we can see how much more stuff in here that I'm going to need to add in order to fill in the blanks. I'm going to need to have some sort of big lawn. Maybe there's opportunities in the background to make a fence or something. We want to fill the frame with geometry, right? We want to fill the frame with as much stuff, if you will, to give us a compelling result. If we just simply put a ground plane in there, that's not enough to make this a believable object itself. We need to create a really simple landscape to go along for the ride. Let me show you and illustrate this idea. So if I just went in and created a big rectangle, okay? Yeah, that's better, okay? However, look at this in the background. That's not so hot. A fence in there would break up that line pretty quickly, or some bushes or some trees. You can find bushes and tree models online for free. I definitely suggest you go check it out. I would not recommend modeling trees, okay? There are two things. I'm generally speaking not a fan of stock models, okay? Because as 3D modelers, I think we should build everything. But I'm not going to build a rock, right? I am not going to spend my time building a tree, okay? That is a waste of my time. Because I can go online I can find a whole bunch of good free rock models online, right? I think I did this once. I went into Turbo Squid, which is a great online warehouse for 3D stuff. And I think it was like $5. I bought a tree pack that had like 10 trees in it, right? I could not make 10 trees in $5 worth of my time, right? In the minute that I've been talking, that's about $5 worth of my time, right? That is energy and time well spent. So foliage stuff, let people who are really into foliage make trees and bushes for you, right? Yeah?
And if we download models, how do we import those into this scene as a separate mesh item or into a mesh item?
File import.
File import? Okay.
File import. It really is just that simple. Yep. So start populating your scene with some stuff, okay? With architectural stuff, it's expected that we kind of create a complete picture. Because with an architectural model itself of a house, in the big scheme of things, this could be key artwork that's used to sell a client, to showcase what the new building or the renovation is going to be. It needs to be a complete picture so that the audience understands what the totality of this environment is going to be when the model's done. Okay? So strive to incorporate those little kind of bits and bobs in there, the extra details. It really will make your scene come to life. Okay? Okay, other questions on your house? Other things over the next 7 days? Okay?
So we just have to turn in on next week the research, right?
And the model itself. Yeah, so you are building the house model this week. Just the model, don't worry about shading it and put materials and textures on. The entirety of our time next week is going to be talking about that workflow, because it is different for big scenes. And then I'll get Dominic. Yeah, Ariana, go ahead.
So basically when we're building the house, we're just doing it like an empty structure, like someone was going to move into this house.
You got it. Don't do the insides.
Got it.
Okay? And here's a really great illustration of why you don't want to do the insides. Can you see the inside? No. You don't need to do the inside because you can't see the inside. In addition, Also, don't go crazy with the details. This is a true story, happened in this class a couple years ago on this very project. Someone waved me over to the machine and said, Pat, look at my door. I came over and I was like, yeah, that's an awesome door. It had like raised panels, it had this really cool, like detailed, ornate door handle. I mean, they spent a lot of time on the front door of their house, right? A lot of time. And then I said, cool, let's see what the render. And they showed the render, and all of a sudden, the perspective went to something like this, pretty far away. How big was that door?
Not very big.
Boop, but this big in their render. How big was the door handle that they had? This person told me that they spent like a good 3 or 4 hours on their door handle. It was like 3 pixels, okay? You know, it just establish your basic framing and composition early on. That way, you're not modeling something that you're just not going to see, okay? And this was like the most ornate door handle ever, right? I mean, if it was this is something that, you know, it's like this is a close-up shot, right? This level of detail. But in a wide shot like this, you just didn't see it. Didn't see that. You didn't see all that hard work and all that energy that went into it, which was unfortunate because it was a good model.
Kind of like something you'd save if you were gonna like show an image or just like a pan view video.
Yeah, I'm not saying keep it basic and blocky. I'm just saying don't make a 3 million polygon door handle that's going to end up as 3 pixels in the final render. Yeah, that's a bad day. Paint with a broad brushstroke, kind of like I've done here. Okay, try to get the overall house done first. Establish the correct proportions and the basic mechanics of it, and then start adding layers of detail.
You want us to make sure it's ready for subdivision?
So this is probably not a great model to subdivide. Subdivision surfaces really only need to be applied or considered on surfaces that are curvy. You know, on planar shapes, go crazy.
On the Ferris wheel, trying to get the arms to work correctly and trying to get them to subdivide. I think I spent like 5 hours on like one section just trying to get the selections right. And I just couldn't get it.
Yeah.
And I eventually I just said, whatever, it's welded or something. So.
Yeah, and that's a good, you know, that happens.
Because I thought we were trying to, I got the impression that we were trying to get everything to be able to be
Yeah.
subdivided, but.
It's a good practice. It's a good practice. For this, you know, for planar shapes that really aren't going to curve much, don't worry about making a sub-D surface, okay? You can do that, and I think it's a good practice to continue doing that. But there's no expectation that, you know, the walls of your house be a sub-D surface for this model, okay? Now, something like a door handle. If you were doing bag end and having that lovely kind of round door as your front door, then it's different, right? Then I really would strive to make it a sub-D mesh so I get a perfect arc, okay? Flat planar surfaces, we have choices. Curved surfaces, almost always going to be a sub-D object. All right, other questions? Everyone's confident, comfortable, excited about what we're going to make? Yeah, a little bit. I'm excited to see what you get. FYI, you know, this is, you know, one of my big outcomes of this class is to make sure that I'm kind of leading you down a lot of natural paths in the 3D modeling industry. It doesn't take a rocket scientist to figure out that the architectural world is a natural landing point for a lot of 3D modelers. It's really, really easy to build, you know, a house, a remodel, an addition in 3D first. And definitely, I did this once for a client a couple of years ago. They wanted to do a build out in their office, kind of like they in the middle of their office. They wanted to make what I think she called it like a web pod, right? And all their web designers were going to stand in this little pod or work in this little pod, right? And you know, she gave me all the drawings and dimensions and stuff, and she's like, let's make a 3D model of it first, and then we'll give, you know, we'll kind of use this as an evaluation of what we've created. And it worked out pretty well because when we prototyped it and put it into scale, it was way too small. People would be like bumping elbows and stuff, and you know, naturally moving a digital wall is a whole lot easier than moving a practical wall. That's not something you want to discover after it's built. So this is low-hanging fruit for us. In addition, you'll continue to see this in the game world. Okay, I mean, every video game has an environment in it. In essence, what we're starting to work in here is you know, the role of an environment artist. Okay, so there's a lot of natural landing spots for this type of work.
So somebody did back end for this, so it
Yeah.
can be, like,
It can be whatever you
space
want.
house or
Go crazy with it. I don't care. Yeah, I want you to be in love with it. I want you to make something that you're pretty excited to make. Don't make Pat's Barbecue Shack. Although if you are going to make Pat's Barbecue Shack, make it a darn good looking barbecue shack. now I kind of want to make Pat's Barbecue Shack, right? I have this crazy vision in my mind of what Pat's Barbecue Shack could look like. All right, we'll see you guys next week. Have a good week.